In this tutorial video, we're going to look at converting between degrees and radians. So you can see here we've got a little flow chart which shows us if we want to convert from degrees to radians, we can multiply by pi over 180, or if we're wanting to go the other way from radians to degrees, we could multiply by 180 divided by pi. Now, just to make it clear and obvious as to why, you'd remember in a full circle there is 2 pi radians. And if we were to compare that to degrees, then we would know that there is 360 degrees. Or if we're considering half a circle, we would know that in half a circle we have pi radians. The pi radians would be equal to 180 degrees. So if I wanted to write this in such a way, rather than knowing what pi radians is, if I wanted to know what 1 radian was equivalent to, then if I divided both sides by pi, then so if I divide this side by pi and this side by pi, you can see that I'll be left with 1 radian is equal to 180 over pi degrees. And if I was going to If I wanted to know what 1 degree was equivalent to, then I could do the opposite. So again, I know that pi radians is equal to 180 degrees. So if I divide both sides by 180, then I would know that 1 degree would be equal to pi over 180. So this is where our conversion chart that we just looked at comes from. So you can see why we have these values. In question 1, we're asked to convert into radians from degrees in terms of pi. Here we go. I have 90 degrees. So if I'm going from degrees to radians, I'm going to multiply by pi over 180. So 90 times pi over 180 radians. And I look, I've got 90 over 180 is a half, so this would be equal to pi on 2. Then B, I've got 60 degrees, so 60 times pi over 180, which is equal to 60 over 180. 60 goes into 183 times, so that's 1 over 3. So this will be pi over 3. You can always use your calculator to assist in trying to determine what the fraction might be. So for example, with this one, I could have gone 60 over 180, and you can see I've got 1 over 3. So sometimes if the fractions are a little more complicated, you can use your calculator to help you. So I've got 30 degrees, 30 times pi over 180. And I need to consider how many times does 30 go into 180? Well, it goes in 6 times, so that would be 1/6, so pi over 6. 270 degrees is going to be 270 times pi over 180. Again, I need to consider what fraction will 270 over 180 be written as? Well, 270 is actually larger than 180, and it's actually 1.5 times larger. So this would be 3 pi over 2. So if that wasn't immediately obvious, this is an example where your calculator might be useful. You can say to yourself, okay, well, what is 270 over 180? And you can see I've got 3 over 2. I've got 315 degrees. 315 times pi over 180, which is equal to, and 7 pi over 4. Then finally, if I have 540 degrees, it's going to be 540 times pi over 180. How many times does 180 go into 540? It goes in 3 times, so this is going to give me 3 pi. Now, if we want to convert to radians, and we have to do it correct to 3 significant figures, so now it's going to be 36.7 degrees, it's going to be 36.7 times. Remember our conversion chart, if we're going from degrees to radians, we're multiplying by pi over 180. Pi over 180. And then you put this into your calculator. So we've got 36.7 times pi over 180 is equal to 0.6405. Now we want 3 significant figures, so that's 1, 2, that will be our 3rd significant figure, so we need to round it to 0.641. That's 3 significant figures. Now I've got 137.2 degrees, I need to multiply by pi over 180. So again, I'll be using my calculator, so it's going to be 137.2 times pi over 180 is 2.39 radians. So this is 3 significant figures, 1, 2, 3. Next up, if I have 317.9 degrees and I want to write that in radians, it's going to be 317.9 times pi over 180. And again, you can put it into your calculator and it comes out to 5.55 radians. Remember, we could put the letter C to represent radians, but also when we're writing a value in radians, it is acceptable not to include it, whereas when it's in degrees, we have to always include it. And then last one for question 2, 396.7 times pi over 180. The only thing you have to be careful of here is ensuring that you're rounding correctly to 3 significant figures each time. So if it asks for 3 significant figures, you need to make sure that that is what it's rounded to each time. You can see, so here 3 significant figures meant 2 decimal places because that was our first significant figure, then second, third. Same here, same here. This one here you can see is slightly different because there was no value in our units. The first significant figure was in the first decimal place. Question 3, we need to convert these to degrees. So pi over 6, if I'm converting to pi over 5, if I need to convert this to degrees from radians, it's going to be pi over 5 times. Then we go 180 over pi. What you'll see is those values will cancel. So we're left with 180 over 5, and 180 over 5 is 36 degrees. Moving on to the next one, if I have 3 pi over 5 and I want to convert that to degrees, it's going to be 3 pi over 5 times 180 over pi. Our pi's will cancel, and it's going to be 3 times 180 divided by 5, which happens to be 108 degrees. Okay, pi over 18 radians to degrees, so pi over 18 times 180 over pi. Those are going to cancel, and I'm left with 180 over 18. 18 goes into 180 10 times, so it'll be 10 degrees. H, 3 pi over 20 times 180 over pi. These values cancel. So I've got 3 times 180 over 20, which comes out to 27 degrees. And finally, an I have 7 pi over 6, 7 pi over 6 times 180 over pi. These values would cancel. So we've got 7 times 180 over 6, which is 210 degrees. Now, in question 5, you're asked to match the following units, our angle measurements, to these diagrams. So let's go through and just make sure that we're comfortable with each of them. So 70 degrees, if I have a look at each of these, well, couldn't be this one because I know that 90 degrees would be up to there, so could it be something that's less than that? So that there is the, I mean, those two are the only ones that are less than 90, but that is a lot closer to 70 degrees. So F would be the one corresponding to 70 degrees. Okay, so F corresponds to 70 degrees. Now, which one corresponds to 2 radians? Remember, 2 radians means that there would be twice or 2 radii which fit on the perimeter of the arc length. So if we look at B, that's 1 radius, and you can see that approximately 2 of those would fit in. So that would be the best fit. B would correspond to 2 radians. C, pi on 2. So pi on 2 is 90 degrees. I can see straight away that D would correspond to 90 degrees. Then let's have a look. Which one corresponds to 200 degrees? Well, A is slightly great. If this was horizontal, that'd be 180. That's about 20 degrees more. So A would correspond to 200 degrees. Then which one relates to 3 radians? So 3 radians is just less than 180 degrees, because 180 degrees would be pi, which is 3.14. So E would be the best fit for 3 radians. And then finally, for F, we are looking for 0.5 radians. So that is, you can see that arc length there looks like it's about half of a radius, therefore C would represent